First off, happy National Cheese Puff Day. Or Cheese Doodle Day. Second thing, what kind of a class is this? Math class, right? Okay, right? What do you think we're going to need? What have we used every day pretty much all of second semester? A calculator, right? If you don't have a calculator out, Schmeling and I talked about this yesterday. We are so frustrated. You just sit here and you don't participate. So I'll get it later. Well, I understand this. I don't have to do it. No, you have to do it. I've seen your tests. Okay? So you need to start participating more. Everybody should have a calculator out every day. If you don't have one, there's a rack of them right back there. Okay? So everybody needs one out. Everybody needs to be participating. Everybody needs to be doing it. The only way that you're going to get better is by practicing. Okay? Used to be a sports coach here, multiple different sports. Okay? Jackson, I know you play basketball, right? You get better by not practicing? No. Okay? Right? You gotta prepare. Like you going up to Superior tomorrow night, right? Okay? Kind of scouted them a little bit, did what they do kind of deal to kind of practice it, so that you know what they're doing, what to expect. That's the same here in math. Okay? These examples that we're giving you in class, okay? That's your practice for the test. Okay? And right now, you guys made some weird mistakes, like on the test. Like Schmeling and I were going over them, like, where did they come up with it? Where did they even see this anywhere in class? Because neither one of us did it that way. Okay? So just weird stuff going on that. Okay? So be better. Okay? Participate, be active. Okay? All right? 3 reminders for the next 3 weeks. Okay? So first reminder is next week, Friday, is Pie Day. And that's all we're going to be doing. We're literally just going to be eating pie that day. Okay? Formative on the 17th, which is a Tuesday. And then your test would be on Wednesday the 25th. So that's a reminder for the next 3 weeks. Okay? All right. Let's dive into it. So, yesterday, we talked about complex numbers. Okay? And we said that a complex number is made up of 2 parts. What were those 2 parts? The real and the imaginary part. Correct. Which part is which? A is the real. And this is the what? Imaginary. Today we're going to explore other ways of saying that exact same thing. Okay? So we're going to give 3 different forms of an imaginary, of a complex number. Okay? So this is the algebraic or the standard form. That's what we taught you yesterday. The algebraic or the standard form. A plus bi. Okay? If we take that to the complex plane. Now the complex plane is different than the xy plane. Okay? Your standard Cartesian coordinate system has x as the horizontal and y as the vertical. Okay? In the complex plane, we have your real part is the horizontal, and the imaginary part is the vertical. So that the complex number -2 plus 3i would be 2 to the left and 3 up. So this would be the location of z. And we can put that in our second form of a complex number. We can put that in ordered pair form. Ordered pair form of a complex number is the ordered pair on the complex plane. Okay? So that ordered pair form would be A, comma, B. So in this particular case, the ordered pair for the complex number -2 plus 3i would be -2, comma, 3. And we're going to assume that the first value in that ordered pair is the real part, and the second part is the imaginary. Okay? So real, comma, imaginary. So now we have a second way of naming our complex numbers. All right? Let's get a third way. That would be the trig form of a complex number. Okay? What would z be here in ordered pair form? What would z be in ordered pair form? So on my complex plane, I would be 2 to the right and 5 down. So right there would be z. Okay? Now, each and every complex number is a certain distance from the origin on the complex plane. And we're going to call that distance r. And every complex number is on a directed ray that we're going to call theta. And theta is going to be the trig angle to get to that ray. It will be your direction angle, if you will. Okay? So let's take, I'm going to be scrolling back up and back down just so you know. Okay? So let's take our z value, which was 2 minus 5i in standard form or algebraic form, which was 2 comma -5 in ordered pair form. And let's find the r value and the theta value. how would I go about finding the R value for this complex number? So Pythagorean theorem, okay, right? Okay, I get it. Okay, so you would find the. Oops, I was way off over here. Okay, so you would make a right triangle out of it. What is the horizontal value going to be in any complex number? Not this one. I know in this one it's 2. But what's the horizontal value going to be for any complex number? So what left? It's going to be A, right? Okay. So the horizontal part is always going to be A. In this case, it's 2. The vertical part of your right triangle is always going to be what? B. So in this case, it's -5. Okay. So how did Gideon come up with the square root of 29? What's my R value always going to be equal to? Exactly. The square root of A squared plus B squared. Now we've seen that before, except we always saw it before on the Cartesian plane, and it was the square root of x squared plus y squared. Okay? You've actually been doing that since October. Okay? Right? Finding that value, finding these directed rates. You've been doing this on the real plane since October. Okay? We just did a whole unit on it where you did it not on the on the Cartesian plane, but you did it in real life. Okay? You did it on the plane of the Earth with navigation. Okay? Okay? So then in this particular case, my R value would be the square root of 2 squared plus -5 squared, which is going to be R is going to be the square root of 29. Okay. Let me scroll back up. How am I going to find theta? No. The SOHCAHTOA would only give me at most an obtuse angle. And this angle is over 180 degrees. Kind of what we've been doing since October with that one too, right? Okay. So my theta value here is actually going to be my reference angle, and that's going to be the inverse tangent of what? In the complex plane. In the real plane, or in the Cartesian plane, it was y over x. It's going to be b over a. On the Cartesian plane, we drop the negatives to find the reference angle. Do we have to do that here in the complex plane? Yep. We're still going to drop our negatives. Okay? With that being said, have I taught you anything on this slide that you don't know? No. Okay? The only thing that's different is what's to come yet, and that's the form that you got to write it in. Okay? Hold on, these guys are being really loud up in the hallway. foreign language to deal with. They went down that hallway. Okay? So over here then, my reference angle is going to be the inverse tangent of what? Of 5/2? Okay? This is where the calculator comes into play. We should all be figuring out the inverse tangent of 5/2. I get 68.19859 degrees. Yes? Okay. Which quadrant are we in? We're in the fourth quadrant. Okay. So what does that mean for my actual theta? 360 minus the reference angle? 360 minus my answer gets me is 291.80141 degrees. Okay? So that's the setup. Now the answer, the trig form of any complex number is going to be z is equal to r times the cosine of theta plus I times the sine of theta. We're going to teach you something today, but we're not going to let you use it until tomorrow. Okay? And that is, this can be a lot to write out. Because, for instance, for this one, z would be the square root of 29 times the cosine of 291.801 degrees plus I times the sine of 291.801 degrees. Okay? Mathematicians, by nature, are lazy. Okay? So after today, okay, and after a specific amount of problems on your homework, the packet that I'm going to give you today, you can use the shortcut for this. And the shortcut is RCIS theta, where CIS stands for cosine I sine. Okay? So this would be then square root of 29 CIS 291.801 degrees. Okay? But that's for tomorrow. I'm not going to be here tomorrow, so that's why I'm teaching it to you today. Okay? So, there are your three different forms. You've got your standard or your algebraic form. You've got your ordered pair form. and you've got your trig form. Okay. We just demonstrated how to go from standard into ordered pair. We did that on the first slide. We just did on the very last slide to go from standard. We gave the ordered pair, but you don't have to give the ordered pair to go to it. And then into trig form. Okay? The only other way is to go out of trig form and into one of the other forms. Okay? So if you are dealing with trig to, how did I say, standard, okay? If you have z equals r cosine of theta plus I sine of theta, what you're going to do then is you are going to just distribute this r into both of those parts. So you would get then r cosine of theta plus r sine of theta times I. And your A value would just be r cosine of theta. Your B value would just be r sine of theta if you needed to go into ordered pair. Okay. Any questions on that so far? Let's get into it. Okay. So we want to find the missing two forms of these complex numbers. Okay. So we are given standard form here. So that means we need to find the ordered pair form. Ooh, that's bad. Stopped in the middle. Suddenly forgot how to spell ordered. What would the ordered pair? It's still bad. He's bad. Oh, we'll get it right the third time. Third time's the charm. I didn't see it. Yeah. Sorry, Phil. I didn't. Honestly, I didn't see it. All right. What would the ordered pair form of this complex number be? -3, 4. Okay. Then we need to find the trig forms. Okay. So how am I going to find my r value? Square root of, so what that's going to be, three squared is 9, 4 squared is 16, 9 plus 16 is 25, so my r value is 5. Okay. Am I in quadrant number 1? No. Okay, so that means I need to find theta prime. Inverse tangent of 4/3. What is the inverse tangent of 4/3? It sounds right. One three. Okay. Which quadrant is this complex number in? Second. What does that mean for actual theta? $126.86990. So the trig form would be five cosine of 126.870 degrees plus I, gotta move it over a little bit, times the sine of 126.870 degrees, or questions on that? Find me the two missing forms of that one. Questions? I've heard a few. I don't know what you would solve. If you would distribute and you would solve, you would get back to this black line up here.
Oh, okay. All right.
There were a lot more questions when I was writing stuff down. Writing it in which form?
Like the order.
As the ordered pair? Because the ordered pair is real, comma, imaginary, it's assumed that that second one has the I on it. So it's just A, comma, B. Good. Try that one.
Straight up.
Questions? None? Oops, apart. No. Agree? All right. So I just handed out to you the homework packet. Selfish. I get it. Okay. On the first page of your homework packet, I don't know if Brett will show up on here. Okay. On the first page, you don't get to use CIS. Okay. So 1 through 8, no CIS. Rest of the homework packet, you can use it. But the front page, no. Okay. Rest of the time is yours.